Hello, everybody. Can you hear me? Yeah. Okay, great. So we started, yes, touching like the ground like on the cybersecurity yesterday. So today I hope that right now you're all relaxed and well fed, so we can proceed with the security stuff. My presentation here is called Cloudflare for AppSec, but to be honest, this is organizers who named it, and I didn't know what to talk about like till very recently. So AppSec is very obvious for Cloudflare. I believe we don't need to introduce Cloudflare you one more time. You know what we do. You are more or less familiar with the concept. So I prepared the thing that is around the AppSec, but much more interesting. Let's start with the, I think, okay, I'll be clicking it manually. So, sorry. So, let's start with, the warm-up. Right now, AI is the next big thing. Everyone knows about it. But what I would like to ask you, do you know how long did it take each of the technologies here to get to 1 million users? So the mobile phones that were introduced first in 1983. Do you have any rough idea how long did it take to get to the user base of 100 million? It took them 15 years. Then when World Wide Web gone public, how long did it take World Wide Web? 7.5, 7.5 years. Yes, almost like. Then the social media. The biggest was the Facebook. It took them 3.5 years to get to 100 million people. And how long did it take? Not the AI, right? We used AI for a long time. So let's talk about the ChatGPT. When ChatGPT gone public, how long did it take them to get the user base of 100 million people? 2 months, exactly. It was just 2 months. So right now the change is so fast, and it is affecting cybersecurity as well. Right now, when we're talking about the automated traffic and the bots, so historically bots were like pretty easy. Heuristic analysis, we know the IP, we know like some like contextual factors. It was enough to identify the bot. These days, modern bots, they have computer vision. They can like evade like any visual challenges like CAPTCHAs. They can solve CAPTCHAs. They can rapidly change the IP addresses, the behavior, the many different factors. It's much, much harder to track them. And the most sophisticated modern bots, they are AI amplified, let's say. They are using also the learning mechanisms to avoid detection. What also it brings like to the table, that AI modified bots, they're infecting the devices much faster. And botnets, they are getting bigger and bigger each year. For example, last year, and these are just the attacks on our network. The biggest attack in the history of internet, the DDoS attack, was around 4 terabits per second. Just in a year, recently in October, we stopped the attack of 29.7 terabits per second, which is like more than 8 times growth. And this is like what's actually happening right now. Behind this one, there was one particular botnet that is standing behind this one. Anyone knows the name? It was all over the media right now. So the botnet is called Aisuru, and it's built like on the on the ruins of the like previous big thing like Mirai botnet, because FBI they busted like the organizers of Mirai, and Aisuru grown like on top of it. But right now, these days, Aisuru has more than 1 million devices infected, and just for you to know, these are mostly routers and CCTV cameras. So just IoT devices. And what is interesting, that botnets previously, they had this business model. Botnet as a service. You can pay to someone like to get an attack. You want to attack the competition, you want to attack a government even. And this is, I don't know how much they make money. They don't publish like the official results, to be honest. But it wasn't profitable enough for these guys. So they decided a bit to change like the focus. They're not just doing the attacks like as a service for the cyber criminals. They moved to the residential proxy. Anyone knows what residential proxy means? And how it's different like from the standard VPNs or... So what residential proxy is? When Aisuru is, for example, infecting your router, so in the darknet, they have like, let's say, 1 million devices infected all over the world. They can sell the capacity on your router for the hackers to do the attacks towards basically anything. Instead of going like with their own IPs or IPs from cloud provider like DigitalOcean, they're using residential IP addresses. It means that your IP address or yours IP address that already has a reputation in the internet. And you are using it simultaneously. They're not using like the full capacity. They don't want to be detected. They're using like 7% of your internet traffic and just doing like shady stuff on the internet. And for any organization in the world, it's pretty hard to identify those. Because at the same time, you're browsing the internet, you're working from your computer from home, you're watching Netflix. And like we need to differentiate this particular request that is actually not yours. So these guys, from where, like how they are like infecting it, mostly through the end day attacks. So what is end day? Everyone knows 0 day. End day, it's when it is a known vulnerability that actually also has a patch already, but you just don't, you haven't patched your physical device. It means that, like, I don't know, you have a camera like in your garden, you don't usually patch it frequently. Even if the manufacturer, they already published the patch on their website, you won't like download it and patch it immediately. So they use those because they know about those vulnerabilities, they are on the internet, and then they can set like their AI model just to easily infect those. But this is the proxy, like residential proxy. And this one is used by the hackers and attackers. But it's not the only thing. There are legitimate companies, the good guys, that also working or operating the same business. What is the difference? These ones, they are not selling it to cyber criminals, but to advertisers, to AI models to train on your traffic or using your IP, etc., etc. And these ones it's actually even simpler to get infected with this type of residential proxy, because what they do, they have contracts with the VPN providers, free VPNs. They're giving them IP addresses of their users. They are actually the biggest part, I would say 80% of the devices they have, they get from the contracts with the mobile app manufacturer or mobile app developers, sorry. So what they do, you have a free app, usually it's ad blocker or some stuff that you need to run constantly. And it is, for them, it is a way to monetize it. So the guys with the residential proxy, they come to these developers and say, okay, we will put our SDK there and a proxy where. You put in the terms and conditions that just 10% of the traffic may be used by someone, and they will just get to download your app for free. And you will get monetized from us. You don't need to bother your users with some ads on top of it. And basically, this is the way how these legal guys doing this residential proxy. Do you know how many IP addresses right now are running more or less, let's guesstimate. How many IP addresses are mixed up in the residential proxy business right now around the world? 250 million. So 250 million IPs all over the world are doing the residential proxy. And why it is a problem? Even though everyone, ourselves, any other provider, we all have machine learning, AI, everything. It's a big difficult, it's very difficult, to identify these residential proxy guys. And even with the ML models that have trillions of requests every day, heuristic analysis, AI bots, it's very hard. Again, because they're using the same IP as you. We don't even have just the bot management, right? We also use the so-called attack score. It's also an ML, it's machine learning. What's the difference? So the lower score, the worse. If it's 1 or the low score, we know it's bot. And the same for the attack score. There's one, let's say, algorithm running for the bot management and one for web application firewall. If it's vulnerability scanner, we know that it is a bot and it is also an attack. Both get low score, gets blocked, right? For some type of activities, for example, hackers, it's real life user, it doesn't get the low bot score, right? But we see that it's trying to find vulnerabilities, it's attacking, we give it the low attack score, right? And this way we are analyzing it. And even these mechanisms, they didn't work very well with the residential proxies, even this. So we were teaching our ML8 So it's version 8 already of the ML, just to tackle, like, it was one of the points. We wanted to tackle this residential proxy like business, because basically Isuru, they just like, it's recent things, like it's just happening for the last maybe 5-6 months, right? So we put a task like, okay, let's try to like teach our ML to just differentiate these residential proxies, but not by IP. We cannot use IP anymore, because IP is the same as yours. We need to differentiate it by the every and each request coming from the same IP address. And the difficulty is with a residential proxy. As I said, there are like 250 million approximately right now, maybe a bit more, a bit less, but they are swapping the IPs for each request sometimes. So the bot, first time it gets from your IP, the second request flies like from a different IP. You don't get like hundreds of requests from the same IP from them. They're just evading this way, they're evading any like challenges from like vendors like ourselves. So this was the main challenge actually, that they are using millions of real user IPs and swapping them constantly. When we first, I will not go deep like into how we trained the model. We have it on the website, by the way, you can take a look in our blog post. But when we first started running it, and every time we are introducing the new machine learning model, we are running it in so-called shadow mode. What it means, ML7 is still actively working for all the users, but ML8 is just working in the logging mode. It's just learning, and we're looking from the world data, like how many detections we get. So we started getting information about the residential IPs and where they're coming from. About like the real world data. Most of them is no surprise is coming from like the US. A lot of IPs are coming from, right now, it is Ukraine, and it was Morocco and Algeria, so from Africa. Basically, the countries that are trying, using VPNs a lot, using ad blockers, these kind of things. It was surprised, actually, that from Russia, there are not many IPs coming, maybe because everyone is already blocking Russian IPs. So it's like there is no point, to steal those, I guess. So, yeah, and what is interesting, when you're taking any particular residential IP, we were trying to get the information, what % of the traffic is real user traffic, and what % of the traffic is actually coming from these automated users that are trying to exploit your IP address. And it is close to 20% at the peak times. It's around it usually goes from 12, 13 to 20% at peaks. So every 10th request coming from your network, if you are using one of these free apps, you may not even know about it. It can be potentially coming not from you, but from the bot. And these is just for the residential IPs and set number of residential IP addresses. So these spikes, these are the bots actually using these IPs. And why there are spikes? Because for the mobile apps, if you have a free app downloaded, it's actually using your traffic only when the app is running. It means you're working from your computer during the working times, or using some ad blocker when you're browsing the internet on mobile. It will be working only during these times. So with this ML8, what was done? Great. So basically, in the first hours when we implemented it, every hour we were revealing 17 million of new residential IP addresses. Every hour. So yeah, and it's it gets to the point of 250 million. Right now, I believe it's a bit more. So what was also great, so 95% of these evasive attacks that were previously a problem, we are right now capable of identifying. They were just we were not capable of predicting where is your request and the request coming from this residential bot. But right now, it's not a problem anymore. And what is actually interesting, that benefit that we didn't expect, but there are a lot of bots on the cloud infrastructure. Everyone knows it. Bots, they're using DigitalOcean, they're using AWS, they're using other providers. There was spike of 20% more detections of bots coming from these cloud providers, because right now we are not anymore looking at the IP. We're identifying them by different signals, more signals than before. And right now we're also better identifying these guys. So, but as well, so this is residential IPs, but it is not even the biggest problem. So the biggest problem is the AI amplified bots, these AI amplified bots, because residential IPs is one of the technologies they're using. And for those bots, for a long time, what we've been doing, we are analyzing the aggregated traffic from all our network. Right now, it's roughly it's 80 million requests per second and around 6 trillion requests per day that we are right now seeing on our network. And we were doing this aggregated learning, let's say, because we don't want to expose the user data. We never go to the website content and never expose the customer's data. But in the real world right now, what is actually it's needed to be done. So for the enterprise customers, we enable them an opportunity to turn on the ML models that will learn on their traffic. We will not use it for anyone else. It will be just for them. And why we're doing this? So we call it the personalized security because, for example, you are, I don't know, retail business. What abuse, what may be called as an abuse to your website, not necessarily abuse for someone else. Retail business, they have seasonality, they have spikes. So, and this was the first step. We need to establish a dynamic baseline. What it is we need to learn what your actual traffic looks like throughout the long period of time. Because, for example, I have the customers, the software developers. They have releases every quarter. During the release, traffic goes 3 times higher than at any other time. So first step was to, for these customers, establish the dynamic baseline just to avoid the false positives. The second one is identifying the anomalies. And anomalies here is not one-to-many, but just for your particular website, for your application. So what is anomaly to you? As there are some examples, for example, for gaming, it's when it is a low volume requests and methodical scrape of player information. For the retail, it may be the content scraping when they're going through your in alphabetical order or through the cart without cart interactions through all the e-commerce products, let's say. For the media, it is the thousands of blocking scripts that are using your URLs, etc. And what is the step number 3? It is identifying these bots that are anomalies just to you. So you identify the bot and you create automatically create the rule just for this particular customer. And more to it, so you also adjust, we are also adjusting the bot score. For example, one bot may be scored differently for 2 different customers because for them, this particular behavior is an abuse. So we are lowering the score and this customer will be able to identify it quickly. If they have the rule that's set, okay, block everything that is in range 2 to 29 because it's most probably bot, we'll lower the score for these users through the period of time and then it will get automatically will get to one of those rules. This is personalized security now. And what is actually interesting, so with this personal security, for the 5 beta customers, we're able to detect 34% more of these abuses. So basically, this 66%, this is what we would have identified without the personal security for these enterprise customers. And there were 47 more million requests that we identified with this turned on. And so this one is interesting. Okay, we know how to block the bad guys. But what if we need to whitelist the bots, the AI bots and AI agents? And we need to avoid any false positives. We need to be 100% precise who can interact with us. So with this challenge, actually Visa and MasterCard came to us, and a couple of more, but Visa and MasterCard, they already have it implemented. So basically, what they do, they are working with the merchants all over the world, and they are authorizing the transactions. And right now, many e-commerce platforms and other customers, they're already purchasing things using AI agents. So in a chat, like Shopify, also one of our customers. So someone in the chat at Shopify writes, please find me the new shoes. I would like Nike, this size. So can you find it? The AI, agentic AI looking for it at the millions of Shopify websites, picks the best price, the best the color, the size you need, and goes to the transaction. But how Visa and MasterCard could have identified this bot, right? Because when the bot has your financial information, the credit card information, your name, your address, it doesn't mean that they are legit, right? Anyone can spoof this information, try to steal it, and try to interact with their platforms. We have the AI crawl, which is not a new thing. So right now you can block or allow or even charge any AI bot from the known bots, you know, the big models, right? GPT, Bing bot, like Gemini, etc. This is like good enough solution, but not for this particular use case, because you are targeting like just like, you know, the whales, you know. And these agentic like AIs that are purchasing, they're usually the small companies. So we are driving this initiative already like since May this year, I believe, that is called web bot authentication. So what it is, right now to identify the AI bot, IP address and user agent are not enough anymore. Like you can easily spoof the user agent. You can right now use millions of residential IPs. So it is not enough anymore. What is web bot authentication? And we help to realize it to like for Visa and MasterCard. So basically, what you need to do this is a cryptographical authentication for any agentic bot on the internet. If you're a legit bot, so to in terms like to identify you, we need to get the cryptographical key. And how Visa and MasterCard realized it. So the agentic bots that wants to transact with them need to register on their platform and provide them with the cryptographical keys. And then with a platform like Cloudflare, what they do, they need to we need to know several things. Each request from the bot, first of all, it has the signature. Okay, of course, that we will retrieve from the MasterCard or Visa. Then it has a nonce. Nonce, it is a variable part, and without the nonce, you cannot complete the transaction. These two should be present. And nonce is changing with every request. Why we need it? Because request can be spoofed, and if someone tries so-called replay attack, we spoofed your request. We know both variables. We go and try to do something shady. Nonce is changing. If we see that it was already used, you will never get through. And then you need to, of course, for us to identify the bot, it should have the key ID, it should have the timeline when it was transacting with us, and also we need to know the tag. So tag is basically, it's usually like the browse, what the bot would like to do. It would like to purchase, it would like to browse something, it would like to do something else. And this is, on this graph, you can see how MasterCard realized it, this project. So basically, you are a consumer. You have you're confirming the purchase. Then your agentic bot, it goes and navigates to someone like us, right? Or in this case, to us exactly. Then we are already checking them for these keys. And also they send a request to MasterCard. Then we are the ones who validates it. Look up the keys, validate the keys, doing all the checks on our end. And then after that, MasterCard transacts with the merchant. Basically, this is how it's done. And what's is actual benefit for them in this regard? They did 0 infrastructure changes. They haven't changed anything in their infrastructure with implementing this. And right now, they are already have millions of these AI, agentic AIs that transacting with them. They have they're using the same mechanisms as other enterprise customers. They have bot management. They see the malicious bots. They see the residential proxies. They can see buff rules, etc. So they can implement the rules whom they would like to transact with. And this is actually the way. I know that they are big enough just to implement it, but these web bot authentication initiatives that we are driving, we would like it to be present at all the AI bots. And basically, I know that with the OpenAI, we'll already have it. So they agreed that, yes, this is the way to go. We don't want these malicious bots just pretend to be OpenAI. We will do this. And with others, we are on the roadmap also to achieve this. What are the next steps? How it influences the rest of the customers? First of all, for the Cloudflare Workers developers, there is the SDK that actually does help you to work or to develop any agentic AI with this in mind. If you'd like to transact with Visa and MasterCard, there are frameworks that will help you to generate the keys, to be added to their lists and to transact with them. And also for all the other Cloudflare merchants, this is a great thing that we are adding the rules that will allow you to also work as per this list. If this agentic bot is allowed by Visa or MasterCard, I want them on my website. If they are not, I don't want them to access my website. And there are much more merchants or these card agencies that are coming to be added. And this way, actually, even like smaller companies, they can just avoid some portion of these like bad malicious transaction AI bots. Yep. Any questions?
Thank you, Anatol. We would have space for one quick question.
Okay.
I think then, Anatol, everybody can catch you. Ah, there is one. Okay.
Yep.
Gotta shout at me.
I was curious about your personalized security part.
Yep.
Like you did 5 beta tests, and how you are thinking about scaling this, because personalization is really hard to scale, right?
Yeah.
So it will be like, do you plan on using, for example, AI to scale the personalization, or you have like specific classes of profiles that you then apply to other clients?
So basically, these were 5 beta customers like on the slide, right? But right now ML8 is already activated, and all the enterprise customers, they can opt in into this. We want ML that will be like adjusted just to our website. They just click like on the toggle and they get it. And this ML start learning on their traffic. It's already done like for all the enterprise customers. So basically, if you are enterprise bot management customer, basically it is available, yeah. And AI is just learning like on your traffic, right? To scale, we don't need AI here. It's just like automatically enabled for everyone. If you don't want to use it, nothing will change for you. You will just like, you will keep using like ML8 still, but without these personalizations. Yep. Thank you.
Right. Thank you so much, Anatol.
Okay. Thank you, everyone.